We wrote this function in our previous videos, I believe, when we discussed arrays. Now we will be talking about closures, so I think it's appropriate to bring it back and then try to use this to help better understand how closures work. Now, a closure in Swift is a self-contained block of functionality that can be passed around and used in our code. So, a closure is a nameless function. It's the function without a name. It's global, and its nested functions are actually special cases of closures. So, closures are global in scope, and then they had nested functions. So those are like special cases of closure anyway. Now, unlike standard functions, closures, they write a parameter list and a return type inside the curly braces. And then usually it's followed by the in keyword, which separate the signature from the body. Now, when we look at the code that we have here, we have a list, an array of numbers. It's integer type, and then here we're performing these sorted dot array dot sorted operation, and then we're passing a closure inside this array dot sorted method here. Now, we're said unlike what is it called? Unlike regular functions, closures write their parameter list and return type inside the curly braces. So this is our curly braces, this and this. And then in here, this closure is expecting two parameters, A and B, both integer types. Now, the closure is returning a boolean, and then this in, which is the standard, the hint keyword, and then the return type is a less than b. All right, so we are sorting this array here. When we sort an array, what usually happens is Swift loops through our items and compares them in pairs. So it's asking this closure a specific question. Should the first item come before the second item? Should the first item come before the second item that is inside this array? Now, if that answer is yes, then Swift keeps it moves the first item before the second item. That will be true. We're talking about Boolean now. So if the answer is true, then what happens is Swift keeps or moves the first item before the second item. Now, if the closure returns false, what happens is Swift puts the second item first. So that logic is consistent with the return here. So if this Boolean, whether or not this Boolean return true or false, this return line will still run. Okay, so I hope we get the idea what is happening here. So in the end, Swift is able to sort the array that we have here, and then when we print this, we get this. So it has been sorted from I think this is ascending order now, from the smallest to the largest number. Now, this is quite verbose in terms of the number of code we have to write. So in the previous, In a previous video, I believe we also did something like, so I'm going to comment this out. So there's another way we could do this using this short shorthand argument name in Swift. So we can do let sorted nums equals numbers dot sorted, and then we could have by, and then in here inside our curly braces we could have a list of parameters. The first parameter less than, so the like the first item less than the second item, like so. So now what this is doing is uh Swift is smart enough to figure this out without going through the verbosity of what we did here previously. So this represents the first item followed by the second item. So we don't have to explicitly do it like this. So this will still work if I save this and then I run this. Let's see. So it works like before. Good. So you realize that this is a comparison, $0 less than $1. So because it's a comparison, it automatically evaluates to a Boolean type. So I just thought I should bring that back. Now we can look at the anatomy of a closure. So we can write the simplest closure, and then we can go from there. So let's see. They are unlike regular functions. So I'm going to delete this, and then we can write the simplest closure. So we could have, for instance, we could have let. How do I do it now? I want to write let message closure. Message closure. What am I doing? Closure. Then equals to, so it's unlike standard function. So we're going to open a pair of curly braces here, and then in here we can say print hello everyone, like so. And then once we write this, we can now call it like a regular function. So we can do message closure, like so. And then we can save this, and then when we run this, we should get hello everyone. So this is closure. So it's so we got hello everyone. So this is like the simplest closure. Now this closure could also take a parameter. So for instance, we could have I don't want to confuse us. So in here we pass this. We said closure has its parameter list and return type inside the curly braces. So this is a curly braces. So if this were to take a parameter, what we're going to do instead, we're going to do this. Inside here, we're going to pass our parameter. So let's say name, and then we pass the type to the string, and then for the return type, we're going to have string. So this is not Boolean now, this is string. That's expecting a string. I think I messed this up. String, and then string in, and then we're going to return what we're going to return here. So return hello, the name, like so. No, 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 I didn't get that right. Name, hello name. Let's say welcome to Swift. Swift, like so. Okay, so this is complaining already. So I hope you get the idea. Pass our parameter inside the curly braces. So this is a parameter name. It's a string type. So in, and then we'll return this in keyword comes. It's a standard with our closure. There are instances we may omit it, but not in this case anyway. All right. So we have to call it. Now, unlike the standard function where we have to use the parameter name as our label, or we have to explicitly write a label here and then we pass the value here using that label. In closure, we don't need to use any label. We just need to pass the value of our parameter. So here I can do, what should I do here? Say John. That's it. Message John. Now, it's complaining. It says result of call to function returning string is unused. Good. So what I'm going to do here is I'm going to do let result equals to this. Okay. Then I can do print result like so. Okay. So I'm going to save this and then let's run it. So we should get hello John, welcome to Swift. So let's run this. Good. So we get hello John, welcome to Swift. We've mentioned that unlike functions, closures do not use argument labels when called by default. So we simply pass the value of our parameter there. Now we also have something known as a trailing closure. For instance, if a function accepts a closure as its last argument, Swift allows us to write a closure outside the function's closing parentheses. So this is, I think this is used in everywhere in Swift UI. I think so. So in Swift UI, they use for declaring buttons or layouts. So let's look at how we might make a trailing closure. So I'm going to delete this, and then what can we do? Let's have a function that filter instead of filtering integer values. Now let's have a function that filters a string height values. So we can have func. Remember, we can pass closures inside a function as well. They can be passed around. Okay, so we can have func filter yes, like this, and then this function is going to take some parameters. So the first parameter is going to take yes. So this is going to be an array of integer items. Okay, and let's just stick with I said I want us to filter string, but let's stick with I think this will do the it will do the job better than if we're to, or maybe we look at that example later. So let's look at this. So the first parameter here is going to be an array of integer values. Now let's pass the second parameter to be our closure. So we can call these matches, and then this takes an integer value as parameter and then returns a boolean bool, like so. Now the function itself, the return type, is an array of integer values. So now this is the body of our function. So the first parameter in our filter years function is an array of integer values. The second one is a function or a closure, sorry, in this case. So it's a closure that takes this integer value, and then the return type is boolean. Now let's see what we might know. All right, it's still consistent with what I'm trying to explain. I needed to be sure I didn't blunder my explanation. All right, so now we can have a variable. So let's say var, let's say filter result, filtered results. Filter result is going to be array of integer values, and then for now it's going to be an empty array, like so. Now we can use the for loop to loop through the items in our array. So we can do for year in years. Remember, years is our array, yeah. Then in here, we want to do if. So this is our closure. If matches has year, then we want to populate this array by doing filtered results dot append. So append method dot append is how we populate array in Swift. Now we pass the year in it, like so. So this is going to populate this array. And then what else do we have to do here? This is our for loop. This, good. And then in here we can do return. What do we want to return? We want to return filter results, like so. Okay. Now the next thing we need to do is we need to figure a way to use our function. Not to mention, we need to make our array of years. No, it's just a parameter here. We've not actually created the array yet. So we can create this array. We can do, I don't know, let post 2000s, and then let's say, no, I don't want to do that. Let's do birth years, like so, and then we can do something like 1995, 2002, 1988, 2010, and maybe 2015, like so. So we are creating our array now. So let's figure out we can use this. Then let's say we can do let post 2000s, and we can call this function now, this filter years function. So now we can do filter years. So you realize we can do filter years. You realize that this is expecting an array as our first what is it called, our first argument, and then it's expecting closure as our second argument. So let's give it that. Yes is going to be birth years, like so. That's going to be for our Harry. And then for our closure, remember we said our closure, uh, it's the parameter list and the return type is inside the curly bracing. So, well, Swift automatically give us this anyway, or the VS Code extension. So, int in bool, right? So we can set a condition here that resolves to boolean. So here we can do year. It's going to be year for our integer value. Then we should have a return type here, but then it has to be a boolean type. So we can say return year greater than equals to 2000. So this is a boolean now. So we only want to return for years that are greater than or equals to 2000. You get the idea? So this is how we're using our closure inside of a function. So remember we said when a function accepts closure as its last parameter or its last argument now, it allows us to define that closure outside of the closing parenthesis. So this is what we're doing. This is the function. So what we're doing inside, this is our closure now. Usually when we call a function, we stop here. But because this function has a trailing closure syntax, so we can use it outside of our parenthesis here. Good. So now what do? We can do, the next thing we can do is just to print post 2000s, like so. And then we're going to save this, and then we're going to run this, and let's see what we get. So it's running. Good. So we have our sorted list 2002, 2010, 2015. I think we've done quite a bit, or maybe we should do one more. Now, Swift isn't the first language to use closure. We have closure in other programming languages as well. We have closure in JavaScript, for instance. I think we have in Python as well. Now, from the name closure, what it means is that it can capture and store references to variables and constant. Well, let me just say it can capture, or it can wraps around closure wraps around the value or data, or is it just program or code outside of its own scope. Now I'm using JavaScript concept to explain it now. So a closure can capture and store references to variables and constant from the surrounding context in which they are defined. So Swift uses to undo memory management. So let's look at a small example to try to drill this into our understanding. So I'm going to delete this. See, I'm quite, my pace is quite slow because I want us to be able to code along. So let's write a function that runs a total generator. It's going to be a function that returns a closure, and then every time we call the return closure, it increments a running total, and then it's captured from its original environment. So let's look at how we might accomplish this. We can have a func make incrementer, like so, and then this function takes a parameter, amount, the type is going to be integer, and then for the return type, it's going to be a function, like so. So this return type is a closure, not just a standard function. So this closure is returning integer as its return type, and then we can have the body of our function here. So this is a function that takes a parameter and then returns a closure. So let's make a variable here, var running total. Let's start with 0, and then in here we can say we can create a closure that captures both the running total and then the amount that our make incremental function expects here. So we can say remember how we create closure, let incrementer so make incrementer, that also we used before. Okay, so let incrementer, then we have this and then we have return type integer, and then this equals to this. What am I missing? Then we can do running total. We can increment this amount, and then we can return here we can return running total, like so. Of course, we still have to return this incremental closure here. Okay, so here we have then we have return incrementer, like so. Good. So all that error is gone now. Okay, so you take a look at what we have here. Now we need to make use of our function. So what we're doing here, this function, okay, I think I've explained that, so there's no need for me to go back. Then we can do let increment, let's increment by 10, for instance, 10, and then here we can say make incrementer. Then we pass the amount, let's pass 10, yes, since we're incrementing by 10, and then we can print our result. So print increment by 10, like so. Now pay attention to this. I have to call this function here, like so. So here we're going to get, I'm going to close this. I want to show something. Remember we said that every time we call this function, it returns a closure. And every time we call the return closure, it increments a running total that it captures from its original environment. So I'm going to show you something. The first time we call this function, we're going to get 10. So let me just run this. Okay, so we get 10. Now, because this closure here, it closes around this environment, when we increment it one more time, it's going to increment by 10 again. So I'm just going to copy this and then paste like this, and then I'm going to run it, and let's see what we get. The first time we got 10, it's running. Let's see again. Now, cool is that? Now we get 20. If I run it again, it's going to increment by 10 because this closure here, it keeps closing around, it captures the code around it. So guys, I'm going to stop for now on closure. I'm sure we're going to be encountering closure more in the course of our series. So thanks for watching.